Welcome once again everyone to the Singular Numerical Relativity. We know that scientists have been expecting a theory that will be called quantum gravity. And they believed that quantum physics and general relativity could come together if the quantum gravity will be found. However, it came with a different name. The name is the Singular Numerical Relativity. And the reason is that the Singular Numerical Relativity is going to deal with all the issues in physics. Not only gravity is the issue, but there are so many other problems that it will be solving. Therefore, gravity is just one of them. So today I will discuss with you gravity and the power of n+1. The search for the force that let things fall down started a long time ago, and so many people came up with different theories explaining the force that lead things to fall down. Then only one person was successful because he was able to conduct an experiment that we are going to see now. And this person is known as Galileo, the mathematician of the 16th century. Galileo was so much fascinated by things falling down, and he wanted to really verify a law that was already given before, through observation also. And people believed that if I have a paper and a stone, the stone will fall faster because it is heavier. The paper will fall slower because it is very light. But Galileo challenged this idea, and he concluded that all things, if we remove the air that disturbed them in the course of falling down, then all things fall at the same rate. Therefore, to know exactly how fast they fall, he set this realm. He used a ball. This ball will be rolling over this realm. Then, to know exactly how long it traveled, he was able first to calculate the circumference of the ball. And he noted one full tour as 1. So when it rolls a full tour, then that's 1 unit of time and 1 unit of distance. Then he got the time, and he started beating the time according to what he found. And when the time goes to the second beat, he observed that the ball will roll 4 times. So if the time is 2, the ball will roll 4 times. If the time is 3, the ball will roll 9 times. This is amazing. So he concluded simply that the distance that the ball will travel is proportional to the square of time. And because of this discovery, we have done a lot already. We were able to develop so many things, and this took us to the moon. It took us to Mars. It took us to Pluto. However, let's see what the singular numerical relativity is going to say about this. When I discovered the structure of numbers 3 years ago, I never knew about Galileos Experiment. I learned about Galileo's law of falling object, falling at the same rate. That one I knew. I learned about his telescope, observation of space, about him. I knew him as such a person, but the mathematics I never knew, the issue of mathematics about him. But curiously, 3 years ago, when I discovered the structure of numbers, I found that numbers, they move. When they stretch, they move towards the levels of variability, and they take different values at each level. As you see here, this number 4. But it's not all about number 4 here. We are just talking about the number of levels. If it will move to the first level, it will take how many locations? 3 locations. Because a number can be in different places at the same time. Many places at the same time. When it moves to the second level, it will take 5 locations. We call values. Third level of variability, it will take 7. Fourth level, 9. Fifth level, 11. So this relationship is very clear. We were able to demonstrate it here in the structure of numbers. It works perfectly. No error at all. But we see now in terms of space. In Galileos Experiment, you talk about distance. Actually, distance means what? Space. And here, the space, how it is formulated. But first, a number naturally occupies one area, which is squared area, which is 1 squared, and that's a level 0. So at level 0, the information area is 1 squared. Level 1, 2 squared. Level 2, 3 squared. Level 3, 4 squared. Level 4, 5 squared. And you see the relationship here. What we found is that we are using the level number plus 1 squared. So we have to get level number plus 1 squared. And this is what? This is what we are going to emphasize on. The number of values per level. To show you that, we see here. At level 0, I have only one value. Level 1, I have 3 values. What are these 1, 3, 5, 7, 9, 11, 13, 15, 17? What are they? We know them as odd numbers. But these numbers represent the squared arrow. Meaning, it means I go from 1 squared, then for me to form the next squared, I need to add 1, 2, 3. I will add 3. Then it gives me, including this one, becomes 2 squared. So 1 plus 1 squared, 2 squared. If I go to the next level, which is level 2, my number of values will be 2 times the 2, which is the level number, plus 1. It gives me 5. These are the 5 locations, or 5 values. The values we are talking here, they correspond to what we saw in Galileo, what we call the bits of distance. Those bits of distance. So the relationship here is very clear. That if I have 1 will give me 1 plus 1 squared. 2 will give me 2 plus 1 squared. 4 will give me 4 plus 1 squared. 11 will give me 11 plus 1 squared as surface of information or number of bits corresponding to the distance that the ball will travel. So who is wrong? Who is right in this interpretation? Let's go back. Go back to Galileo's experiment. You see here, the ball in the first Galileo time, the first bit of time, it traveled only one time, this one here. That gave us the result of 1 squared. Where the 1 came from? The 1 comes from 0, which is the starting time, plus my ending time here, which is 1. 0 plus 1. But what is 1 here? 1 is 0 plus 1. Therefore, the calculation is 1 equal 0 plus 0 plus 1. So you get 2 times 0 plus 1. 0, I said this is my starting time. And why I'm talking about starting time? Because you see well that the ball doesn't travel in a uniform speed. It doesn't travel with a uniform speed. here it travels in the same unit of time, it travels once only. But here it will travel 3 times. Here it will travel 5 times. The next 7 times. So it is changing. And because of that, we have a constant. So we have to conclude that if my time increases by 1, then the ball will travel 2 times my initial time plus 1. So this law is inscribed into the system of the universe. So this is, you cannot debate on this. Even if you come from heaven, you cannot debate on this. Because what Galileo observed was the key for understanding how space-time work. And you are going to see that if we understand perfectly this notion, we will be able to quantify the information in the universe. It's very easy. We will know how much information is from this point to the other point. Here we are dealing with only 1 of plus 1. What about if it becomes plus 10? It can happen. What about if it becomes plus 100? So that's the point. How will you calculate that? Therefore, the formula of Galileo, although it gives us the results are good, fine. But that formula is giving us the idea of uniform speed, meaning the speed like it's the same with the proportion that we have drawn here. But the reality is that this body is accelerating, and when it accelerates, it has a certain rate it is following, and that rate is this. So what matters most, it is not this 1 square, that's what matters most. What matters most, how fast it traveled in the first bit of Galileo time, how fast it traveled in the second bit of time, the third bit of time. So this is what, because we have to know how many events, these bits of time tell us how many events happen in that bit of time. Here we are quantifying the bits of time in terms of space and time. So even, let's say a comet comes from space to hit the Earth. It comes with a certain speed. But how will you measure that? Only at the impact. You will measure only when it hits, the time it hits, that's what the speed is. You will say this body has been traveling 3,000 kilometers per hour. Only at the time it hit. But the rest there, what happened there, you don't know. How fast he was traveling exactly. But when it came closer to the Earth, it speed up. Following the law of gravity, it will speed up. So, how fast You can know it only at the moment of impact. Therefore, in calculating all of this, we need to really cut space and time into portions, because only in those bits of time that we can tell that at this time how many events happen. At this portion, how many events happen. Do you understand what I'm talking about? This is the reality. So, the experiment of Galileo was not wrong. And even his conclusion was not wrong. However, we are taking things one step forward. Because now we have gone to the fundamental level. Why we have been experiencing infinites in our equations. When we try to apply the equations of Einstein to the black hole, to describe information in the black holes, we get infinites. Why those infinites appear? Because our equations lack the arrow of time. When I'm speaking of the arrow of time, I want you to see this here. So every moment, because numbers works, which are the fundamental building blocks of space-time, and which are giving command to everything, including what we experience as gravity, numbers dictate this law. I told you that no one can debate against what Galileo discovered, because it is there, and that's is being proven here. So here, the squared arrow here is very important. Why? Because we have to quantify space and time. We have to quantify them. Then now we will know, because our goal in this, doing all of this, it's about the information, how much information we can find, and this will give us the DNA of the universe. It will give us the map of information of the universe. We will know all about the information in the universe. There is a map, huge one coming. We have it. So as soon as you listen to what I'm saying here, try your best and join me. Let's work together. Get the idea from me and apply it. That's all. Get the idea and apply. Then you will see the result of what I'm saying. But I think no one should take the initiative of going alone. We need group work, meaning all the brains of humanity must come together and do the job together. Because there is a lot of things based on this one, a lot of things we are going to talk about. So now you know that Galileo was the person who came really closer to understanding the fundamental rules of the universe accurately. Unfortunately, things went in a different direction. Anyway, we have to accept that. But because after all, we have what we have today. Without all those things, we cannot have the computers, cameras we are using here. All of these could not exist. But we could have done better than that if we followed what the information is telling us. So this is a fundamental law. Gravity now can be touched. If you understand only what I am saying, then no problem. So please join me and we will work together to solve all these issues and march forward. Thank you very much.